talking to my 10-year-old son this afternoon, and he said, "Daddy, are you gonna talk about Pokemon today?" Of course I'm not. I'm going to be talking about neural networks today. Typically, when I work for a company, and whenever the typical programming use cases is you have an input that you're given a task. There's an input that you're required to work on, and then you ask your boss, "Where am I going to get this data?" And then you build the algorithm, or to do the calculations, and then it might be a report or something. Then you spit up or determine, to create an answer. You build that report, you generate calculations, and you show the answers to the user. In machine learning, just to go back, it kind of flips that scenario where you have the input and the answers, and what you're trying to do is you're trying to train the computer to learn the algorithm for you, to generate an algorithm for you. And so it's a machine learning primer. The programming is on the right side, where we specify the input and algorithm and the answers and do some calculations. And on machine learning, we would have input, then answers, and you're training the computer to learn an algorithm for you. In machine learning world, that's what we call training data. And in order to do the training, we need training framework in order to teach the computer. And what it spits out the model that you would use it to your program, and then it would close the loop. And in your program, what you would use in order to incorporate that model to your program is using the runtime, machine learning runtime. And then, of course, as you improve your machine learning, as you improve your process, you would collect more data, collect more answers, and that would turn feedback into improving your training data and improve your model after that. So typically, a data scientist, what they would do is they would create a PyTorch, or you would use PyTorch to create a program to train the computer, and then they would typically run it locally on their machine, with their CPU, all that. But as we've seen on the other slide, we have different types of frameworks that they can use, that depending on what is needed and what the skill set of their data scientist is. And of course, when we create programs these days, we have different deployments. Sometimes we have to deploy it through, through Windows or Linux. You would deploy it on an Android phone or an iOS phone, or even deploy it in the cloud. Also, you may have to deploy, each one of these devices may have different processing units. It could have a GPU, FPGA, ASIC to start with, and that's what ONNX does. It is the bridge between the machine learning frameworks and also the deployment. So ONNX is an open neural network exchange. It is an open format for machine learning models. It allows AI developers to move models from other deep learning frameworks in interoperability between frameworks. One thing that I got interested in, wanted to learn more about ONNX, is because it was started by Facebook and collaboration with Microsoft, but all through the years it has lots of partners, not just related to the frameworks, but also the devices, how you would run this on devices. So today we've talked about, kind of get a little bit of idea of what ONNX is. And our agenda today is we'll create, learn how to create ONNX models, and then how to deploy ONNX models. I'll start with that. So this right here, what we're trying to do first is, let's start with the creation part. How do we create the models? And then we'll go to the step 2 later on and do the deployment. Data scientists, I mean, are the ones in your company that, if you have, like in a restaurant scenario where they are the best chef in the world, or they are the best, they're the ones who would try to figure out the secret recipe and try out different, different ingredients, different, different types of ingredients, different type, how you would cook it and all that. And these days, with all the, with all the different restaurants that are closed right now, and since we're staying at home, we've been cooking more and trying out different things, different ways of how you would cook things, just to spice up our life. So the way I see it is, data scientists in your company are the ones that, they're the chef at home. They're the ones that specializes in finding the secret recipe for your company, so that it would make a difference to the others. So there are 4 ways to get an ONNX model. One of them is through getting them through the ONNX Model Zoo. Another is through Azure Custom Vision Service. Then converting existing models, and then of course training them through Azure Machine Learning. You can use automated machine learning in the cloud. And we'll go through each one of them. ONNX Model Zoo is it's on GitHub. It's where you can download. It's a place where you can download all the different open source models that is already converted to you in ONNX, and that's available. So if you just want to start incorporating this in your program, maybe there's a model that is already existing out there that you can download, and it might be worth looking into. Like in this case, there's MobileNet, ResNet that has already been converted for you, and it's the easiest way to get started with ONNX. Another one is through Custom Vision, customvision.ai. This is where you can create and upload your images. Like in this case, I'm uploading pictures of fruits, and I'm tagging, hey, these are fruits. And then training them in the cloud. And a way to export your model in ONNX, and then incorporating it to your program. So there's a lot of converters out there that is available. So if you're a data scientist, or if there's data scientists in your team, there's a way you can convert, TensorFlow models to ONNX Keras model or PyTorch models, and be able to start using it through your application. So there's 3 steps in how you would convert models. One is load the existing model, do the conversion, and save it to ONNX. As easy as that. So I've been talking about ONNX models, and sometimes it's harder to visualize what it is. The way I see it, it's kind of like PDF of, because it's interoperable, right? So it's a PDF version of neural, of representation of your graph of operations. So there is actually a tool that you can visualize what the ONNX models looks like, and there's a link down here at the bottom that you can use. But it looks something like this, where you have your input up here in the top, and as it's processed through, you can see the operations that it's actually using. So how you would use it in Keras, how you would convert to Keras to ONNX. At the end of the day, the important part here is this one right here on this, where you have the convert Keras and then you save it to the model using this keras.toONNX save model. Also, same way in PyTorch, you would, in this case, you would load your model. After you load your model, this one helps us identify later on when we visualize it, or it helps the developers kind of know what the actual input is and the output, once it's labeled. So when you export it to that ONNX file, these are the inputs and outputs that you'll be able to identify, that the developers will be able to identify later on. There's also a way you can use command line to do the conversion. The advantage of this one is now you can start doing it, as part of your CI/CD build, and do that. The training models in Azure machine learning, the advantage of that is you can quickly scale with GPU clusters up in the cloud. You can use automated machine learning, do hyperparameter tuning. You can easily deploy it and integrate it with your CI/CD tooling. So that makes it the way I explain it is that, wouldn't it be nice if we can have a container, a way for us to be able to version our models that gets generated? So the advantage of that would be in this side right here, where you have a registration and model management through Azure machine learning. So it's kind of like in containers, right? They have a container registry. Now you have a model registry that you can start incorporating it, and so you can have versions on these models and help you with your deployment. One thing I always wanted to talk about today is also the tensors. Not a lot of us, as developers, can understand what tensor is. And at the end of the day, the way I see it, it's a high dimensional matrix. It's a way for us to have like in this case, tensor of dimension. This is tensor of one dimension, and be able to identify, hey, this is one dimension. In this case, this is 2 dimension, tensor of 2 dimensions, right? It's a matrix of 6 by 4. And this one is tensor of 3 dimensions, where you have, if you think about it, mostly images are like this. You have red, green, and blue of 2 by 2 by dimensions, right? So where is ONNX in this world? We're going back to that slide that ONNX is this part right here. It allows you to be able to export it to this model, do the conversion here, and we'll be able to use it with our runtime and interoperate. So now that we know how to create ONNX model, we're going to go to the next part where we deploy the ONNX model. How to deploy them. So a while ago, I talked about being the data scientist, generates a secret recipe. And the way I see it is developers, software engineers like me, we specialize in, like in this case, starting a bakery. There's the difference between a baker versus starting a bakery. It's a different skill set. A baker would be, or a chef would be someone that specializes in creating that secret recipe for you. We as software engineers or developers, we specialize in figuring out how to operationalize, how to put it in production. Like in a restaurant situation, where we know where to put the cash register, right? We know how to integrate it with Uber Eats or for some reason, or how would you source the data? Where would the ingredients come from? And we create these pipelines, and that's what we specialize in. So this is that part on the right side where we can actually deploy these on different devices, Windows devices, including HoloLens, we can deploy it in the cloud, or we can use converters so that we can use iOS and Android. Whenever we think about deployment, we always have to grapple with the decision. Are we going to deploy these models in the cloud, or are we going to deploy it on the edge? And here's something I would like to talk about. That is on our mind lately is the personal protective equipment lately. If you think about it, what's the difference between cloud and edge? My definition is edge means whichever the processing happens closer to the user, to the needs are. So in this case, I was thinking, do you source it from other country, or if you can build or you can manufacture it closer to where the needs are, the better. So the way I understand, or the way I would see it, is as edge meaning closer to the user, cloud meaning you ship it from overseas. So deploying it in the cloud, you can use Azure machine learning to do that. Where you can deploy it as a web service, right? An API, which is what typically happens when we talk to our data scientists and they create their models, and we kind of box them and put them in an API, and then we hammer that web service and how we would incorporate to our programs or to our applications. And going back to this is that part of that last is where you would do the deployment on here, where you can monitor and deploy the service. Like I said, when we think about deploying, right, to the edge, in the cloud, we typically think about how many think about thousands of data centers, of VMs, or how you would deploy them in the cloud. Well, there's also a difference in when you think about when you're deploying it through the edge. Now we're talking about millions and billions of devices, where it could be a phone, an app, or it could be somewhere in the fog, meaning it's the data center closest to the user. It could be the 5G networks, or the cell towers that can be deployed closer to them, or the gateway that is in the same building. So those are what we need to think about when we're doing deployment to the edge. So why would you deploy to the edge, right? Why would you deploy? Why would you have AI on the edge? One thing is low latency. Think about you're processing images, or you're processing video in the cloud, or you're processing video locally. You don't want to send all that video feed up to the cloud, because you want it fast. You want the results of your processing to be fast, and so that's how you would do low latency. Another one is through scalability. Scalability meaning it's pre-processing. If you have to send all your data up to the cloud, it gets expensive, because there's cost in processing up over there. If you can run it locally on the machine, or a Windows machine, or you can run it locally on the phone, or somewhere closer to the user, then it's more cost effective that way. Another is flexibility. If I'm on the plane, I don't have network connection, so I'll be able to use the application even though I don't have a good internet connection. Another way is, there are cases where, rules and regulations that you should not share or ship your data outside specific network or outside that same country. So that makes it more flexible. You can also use ONNX as an intermediary format, meaning I can convert a PyTorch model, convert it to ONNX, and then from ONNX, I can convert it to run on TensorFlow, from ONNX to TensorFlow model. Then I can incorporate it to my Android application. Another way is I can use it to convert it to, to Core ML. So you can do ONNX to Core ML too. Another one is through transfer learning. If I have an existing model and I want to do transfer learning and do fine tuning, we can do that using ONNX model as an intermediary format. Now we'll talk about the ONNX runtime. ONNX runtime is a high performance runtime for running ONNX model. It's performance focused. It's cross-platform. You can use it for Windows, Linux, and Mac. It supports ONNX ML, also meaning traditional machine learning operations. So it's not just limited to neural networks. And it has extensible architecture with different hardware accelerators. And you'll see that more later. And the good thing for us developers, there's the C# API, C++, C, WinRT, Java, Ruby, you know it, you name it. So you can easily try it for yourself if you are interested in learning more. And there's a GPU version of the ONNX runtime. So how you would do it, use it in Python, you would import the ONNX runtime. There's an inference session that you would pass in your ONNX model, and you use session.run, and you pass in your input data, and it would give you the results. As easy as 1, 2, 3 again. There's also Docker images that you can incorporate this with your application. I would suggest, I would recommend going and if you don't want to install anything in your computer, go to this ONNX ecosystem, spin up that Docker container instance, and you can use it just to do for your to try it out or do conversions. And it already has Jupyter Notebook installed, and it's ready to go. See, this is what I was talking about, where on their website, ONNX Runtime, you can specifically identify, okay, I'm working on Linux in this case, and I want to do C# on Linux, and I have x64 architecture, and I have GPU. And it would tell you right here, instructions at the bottom, how to get started, and which one I would use, which NuGet package. So you can do mix and match, and how when you want to start on this. So I'm going to do a demo next. So I can do that right here. So this one right here, it's on my GitHub page. What I'm doing is I have Jupyter Notebook running C#. And this is how you would download NuGet packages in C#. In this case, you would need Microsoft.ml, different version, the ONNX transformer, the ONNX converter, and the ONNX runtime. As it goes through, of course, this is the program. Usually, you use system.io, Microsoft data analysis, and XPlot. That XPlot is very useful, like in this case, if you want to do graphs. On the next one, what I'm trying to do is I wanted to, if I have a data frames is how you would manipulate, or you would read the data to pass to your Microsoft ML.NET. And I'm taking the first 20 items and I'm formatting it. And I'm loading up a CSV file using this data frame. So this one uses that library or this method right here to display it properly. In this case, I have two columns. Just want to show something simple. I have your experience, and we're trying to figure out the salary. So this is your feature, and this is what we're trying to do our regression. The data frames also helps us kind of understand what our data looks like. Like in this case, it shows you the min and the max, and the average or the mean. This one, I wanted to split our data. Whenever you're working with data frames, you want to split your data into training, test, and train, and then test data. So in this case, I only have like 30 lines or 30 rows. So I split it into 27 and 3. So how you would use this in ML.NET, using Microsoft.ml, and you need to create an instance of the ML context. The ML context helps you get all the transforms, the algorithms that you would need in order to create your pipeline. So in this case, I'm creating a simple pipeline with the features as one column years experience, and we're doing a regression using this algorithm SDCA, and our label column is salary. So now that I created the pipeline, then we start training. Since it is a simple program, it would create a model for you. And in this one, what I wanted to do is to pass in our test data to get some metrics. In this case, I want to see some metrics to identify the loss function, R to score, R squared. Once we're good with that, since it's a simple one, I want to save it to an ONNX model. And how you would do it in C# is you just use system.io and use convert context.model.convert to ONNX. And you identify the stream, and it would generate the ONNX model for you. I can actually go to this Netron application and open it up, and it would look something like this. And it will give you properties. So now, as a data scientist, you can hand it off to your developers. And it would tell them, once they look at it, they would tell them what are the inputs of this program or this model, and what are the outputs of this model. So in this case, I'm not doing neural network. This is just traditional ML. I need, our input is years experience and salary. And then on our output, we identify these are the output. At the end of the day, this is the most important part for us, is what the score is. So going back to the program, so now if I want to incorporate it to my my application, I would use the ONNX runtime. Then 3 steps again. Load the model. You have to new up the inference session. This one kind of explains the input and output. So in this case, what I'm trying to do is I'm building this container where all my inputs would be at. In this case, I have years of experience and then salary that I'm passing in. Since we are trying to estimate the salary or do machine learning salary, see how it's not connected, but it's still needed as input. So we just pass in, only variable. It won't be used to calculate, because how it would go is it would get the input here, do its processing, and we want the score 0. This one we don't need, and so that's what we did here. And then we do session.run, pass in the container, And once we get the result, in this case, I just want to get the score 0 and get the output of that. And it will give us the predicted salary. And this is the data that, I was doing some testing based from this input. That was what we have in our data set. Cool. All right, let me go back to the presentation again. So ONNX runtime, Microsoft, was reading some article about it that they, it's really performance gain is what you need, why you would use the ONNX runtime. And these are some information how different Microsoft teams have used it in the past and how it improved their process. And of course, if you're deploying to Windows devices, you might want to look into the Windows ML, which is available across Windows of family devices in, for Win32 applications and WinRT applications. So the way I explain this, if you are creating a WinRT application or C++, you would use WinML as APIs to connect to your ONNX runtime. And then of course, ONNX runtime has execution providers that connects to DirectML. And then the DirectML, of course, depending on the drivers, if you have a GPU, VPU, or XPU, or however that is. The good thing about this is the ONNX runtime, it automatically detects if you have a GPU or whichever is the best, and if it would always default, it would default to CPU if you don't have any one of these models, right? If you don't have any GPU. So for us developers, it just makes it easy for us. We don't, have the system, identify which one can we use and give me the most performant one. DirectML, if you want to create real-time high control machine learning operator API, meaning if you're creating, especially in gaming, right? This is where you might want to look into DirectML if you're creating games. Here's a reference implementation. Some of the samples that they have out there is using ONNX runtime in IoT Edge. So, deploying it on the edge using with the use of ONNX runtime, where you would take pictures of the camera, use Jetson Nano in this case, in a specific device, and upload it to storage and Power BI to visualize. There's also ONNX JF that you might want to look into if you want to run ONNX models in the browser or in Node.js. It's using WebAssembly and WebGL technologies, and it's for run for both CPUs and GPUs. And it's open source. It's on GitHub. In terms of compatibility, if WebAssembly runs there, most likely it will run with ONNX JS. But wait, there's more. There's also embedded learning library you might want to look into. This one is allowing us to convert. Once we can export it to an ONNX format. From the ONNX format, we can convert it to this embedded learning library that we can start using for devices that does not have a whole operating system or Linux, Mac. This one would run on MCU or the controllers. And of course, after that, this is how I felt like learning more about Azure, learning more about ONNX and all these different its capabilities and how it interface or interact with different execution providers, different hardware. So to recap, what is ONNX? ONNX is an open standard using the right tools for the right job at the end of the day. That you know that you're confident enough that once you convert it to ONNX, that it would run efficiently on your target platform. And how you would create ONNX model, we did look at different ways and how you can convert to ONNX, or how you can download ONNX models. And then how we deploy to ONNX. How do we deploy? We can use .NET, JavaScript, Python. We can deploy it to the cloud. We can deploy it to the edge, and use ONNX runtime to achieve performance. So if you're interested in learning more about me, my name is Dagdag. I am interested in the convergence of Internet of Things, augmented reality, and machine learning. Some information about me: I'm a senior software engineer at Spacey. I am a Microsoft MVP for Windows development. You can connect me through LinkedIn, Twitter, and feedback is appreciated to help my presentation skills, improve my presentation skills. Are there any questions? If you're interested in learning more about the presentation or getting a copy of the presentation, you can go to that link, that QR code. Thank you very much.
Cool. Thanks for your interesting talk about the ONNX runtime. I believe we have a few questions from the audience, actually.
Yes, that's correct. So one of the questions is, here in ML.NET, are you able to import your ONNX model rather than code it up in C#?
Can you import your ONNX model
Yes.
rather than code it in C#? I mean, you can, import it in terms of creating a console application, or how you would load it. It's the same steps as what I did. I'm just showing it in Jupyter Notebook because it's something that might be interesting for data scientists, that hey, there's a C#, but you can use the same application or the same program in your console application. You work with WinForms and all the same steps. Yes.
Thank you. There is more. What is the memory footprint of the ONNX runtime?
The memory footprint. The ONNX runtime, I am not familiar, or I don't have it, that answer for you, but we can research, and if anyone knows, if you can reply in the chat. I don't have it, have the answers for now.
Yes, thank you. And actually, I had a question like this, that are these slides available somewhere later?
Yes, it's, if you want to.
And also some sources maybe?
Yes, it's actually, the cool thing I wanted to show, if you don't want to install, if you just want to try this out and you don't want to install it in your computer, this is cool. So if you go to that, to that GitHub and just click on this binder, and it would spin up a container for you with the same source code that I was demoing, and you can try it out, and you can even modify the program and have fun with it.
Cool, nice. Thank you a lot, Ron.
Yeah.
Great example, the binder thing. I didn't know it existed.
It's a good way to teach. Very interesting.
Yeah. And does it run C# actually? Yeah, it does.
Yeah,
apparently.
It does run C#.
Oh, that's so cool.
Yeah.
That's a neat example to have. So I've got one more question for you. I was wondering, so you can export models to ONNX regardless of how big they are, I assume. So if you have a large image recognition model, you can export that to ONNX and then run that anywhere, basically. You can use JavaScript, you can use iOS. So I was wondering, given that edge devices have a much smaller form factor and less performance in the sense of less CPU power and memory. How would you go about converting a large image model to a smaller ONNX model that actually fits in the memory of a iPhone or an Android phone? Is there anything special you need to do in ONNX, or is there something else?
I'm not sure if there's like a way you can make it smaller. It's more, at the end of the day, these are graph of operations, right? So you have to identify, are the operations that, on this model would run on the, depending on the version of how what you're exporting to, that would identify what operations it can do. So, but in terms of size, I'm not sure about how big or how small the size-wise is, or if there's a utility that you can compress an ONNX model. I haven't seen that yet, but it might be, it's open source, so we don't know. Maybe tomorrow they release one.
Yeah, that could well happen. Yeah. Cool. Well, thank you for your time and for your talk. And if anybody has any more questions for Ron, you can post them in the chat still, or in our Q&A website, chat.globalai.community. And we'll make sure that you get them, Ron, and people get answers from you. Thanks again. And with that, we'll go on to the next session, I think, pretty soon.
Yes.
There's enough time.
Hey, my name's Akansha Malik, and I'm from Melbourne.
Excellent, Sami. It's Val here.
Hi, I'm Alan Smith.
Hi, I'm Amy.
I'm Prasant from California.
大家好，我是卢建辉。